Okay, so in this video we want to look at solving simultaneous equations using algebraic methods. So this should be familiar to you from Year 9. Okay, so we're going to look at both algebraic methods together here in the one video because you should have met them both before. So there's two algebraic methods for solving simultaneous equations, and the first is substitution. Okay. Now substitution means that we substitute one equation into the other equation. Essentially what we're aiming to do when we're solving simultaneous equations algebraically by hand is we're trying to go from having two equations with two unknowns in them to somehow combining them together into one equation with only one unknown. That's the number one goal. Then once we've done that, we can solve for that unknown, and then we can substitute back into our original equations to find the other unknown. So substitution, we're looking to literally substitute one whole equation into the other one. And to do this, because part of the thing that I want you to build on, to work on here, is making the choice between whether substitution or elimination is required. Substitution is definitely the best option when one or other of the equations has x or y as the subject already, because then you can immediately do the substitution. Lots of students waste a lot of time in trying to get x or y as the subject in both equations before they do the substitution, but that's not at all necessary. You just need one equation to have x or y as the subject, okay? And that then means that that equation can be very easily substituted straight into the other equation, okay? So this first example, we have y as the subject in both equations. Now that's not necessary, okay? But in this case we do. So we can think about the substitution both ways around. Okay, if I call it equation 1 and equation 2, okay, I'm going to take equation 1, okay, because equation 1 tells me that y is equal to 4x minus 3. That thing I've just circled in purple is equal to y, which means in the other equation we can replace y with that, okay. So what we are doing here is we are substituting equation 1 into equation 2, okay. So in this instance, we replace the y in equation 2 with 4 minus 3x. And what we've now done is create one equation with just one unknown in it, just x. And so now we can solve this equation for x. So I'm going to add 3x to both sides. That gives me 5 plus x. And I'm going to take away 5 from both sides, which gives me negative 1 equals x. And so therefore x is negative 1. And then once we've got x, we can substitute it back into equation 1 or 2 to figure out what y is. Okay, I'm going to substitute x into equation 1. Doesn't matter which equation, you'll get the same answer in both. And so equation 1 says y is 4 minus 3 times x. So that's minus 3 times negative 1. So that's 4 plus 3, which is 7. Okay, and so therefore the solution to these equations, simultaneous solution, is x equals negative 1. Y equals 7, okay? Just to be clear, alternatively, we could have, as I said, because y is the subject in both of these, we could have instead said, all right, well that's y is equal to that thing. We can substitute that in place of y in the other equation. So we could have instead started by subbing equation 2 into equation 1, which would have meant that we got 5 minus 2x is equal to 4 minus 3x. But that's the same thing. Okay, solving that, it's exactly the same equation. And so you get to the same solutions. Okay. So when y is the subject in both of them, essentially what you're doing is you're saying, well, if this thing is equal to y and this thing is also equal to y, then those two things have to be equal to each other. Okay. So it's not as obvious a substitution process when you have y as the subject in both equations. As I said though, I want to stress that you do not need y to be the subject in both equations in order to do substitution. So in this second equation, we have x is the subject in the second equation. Sorry, in example 2, x is the subject in the second equation. So I'm going to call them equation 1 and equation 2. So I know that x is the same as 2y plus 5. So I'm going to replace x in the other equation with 2y plus 5. So we're going to be substituting equation 2 into equation 1. So whichever equation has x or y as its subject, that's the one you're going to want to substitute into the other equation. It's set up naturally for that to happen. So the first equation is y minus 2 times x, but we know that x is the same as 2y plus 5. equals negative 19. So in doing that substitution, we now have one equation with just y in it, so we can solve this equation for y, and then once we've got y, we can go back and find x. Okay, so we want to expand out our brackets here. Y minus 4y minus 10 equals negative 19. Y minus 4y is negative 3y. Let's add 10 to both sides. That gives us negative 9. And then we want to divide both sides by negative 3, so y is equal to positive 3. We haven't finished because our solution to our pair of simultaneous equations has two parts to it, an x and a y value. It's the coordinates of the point where they intersect. We're going to want to take y and put it back into either equation, but given that what we're now trying to find is x, this equation already has x as the subject, so it's going to be much better to go back into the second equation. Okay? It would work in both, but you want to be strategic about what's going to be the most efficient. So we're going to substitute y into equation 2. And equation 2 is x equals 2 times y, and y is 3 plus 5. Okay, so that is 6 plus 5, which is 11. And so therefore, the solution to the simultaneous equations is y equals, let's go with x equals 11 and y equals 3. Okay. It would be possible in a much more long-winded attempt to rearrange equation 1 to make y the subject. So that's the same as y equals 2x minus 19. And instead then, you could substitute that into the second equation. And then you would solve for x first, and then once you found x, you would find y. So there's always more than one way you can go about it. Okay? It's just making sure that whatever method you choose is ideally the most efficient method and you execute it accurately. Okay, the second algebraic method is something called elimination. And rather than substituting one equation into another, we want to try and eliminate one of the two variables. Okay, so what we want to understand is that if we have two equations, let's say we have something as simple as x equals 7 and y equals 5. Okay, if we add together these two things, x plus y, that's going to be equal to adding together these two things, 7 plus 5. So x plus y would be equal to 12. Similarly, x minus y would be equal to 2. So you can, as long as you do the same thing, you can add together two equations to create another true and correct equation. You can subtract two equations to create another true and correct equation. So what we want to do in the method of elimination is to add or subtract the two equations from each other in order to eliminate one of the variables. Okay. So the first thing you want to do is make sure that your equations are in the same shape. So some number times x plus some number times y equals some number. You want both of them to be the same. So your x and your y terms are lined up. Okay. So in that case, this is already done for us. We've got our x terms and our y terms and our constant terms over there. Okay. So then what we want to look for is we want to look for having the same term in both equations. The positive and negative doesn't matter, but the fact that we've got one y in this equation and one y in this equation is important. So what we're looking at here is we should be able to eliminate y, okay, because we've got the same term in both. And our next decision is, do we need to add together the two equations in order to eliminate y, or do we need to subtract them? Now, if we were to add negative y plus y, that would give us 0. Okay? If we were to add them, negative y plus y is 0, and hence we've eliminated y. We've got rid of y. Okay? So adding is what we want to do. If we had subtracted here, okay, negative y minus y, that's not 0, that's negative 2y. Okay? So it's not helpful to subtract the two equations in this instance. We're going to need to add them in order to eliminate. Okay, so we want to do equation 1 plus equation 2, okay? And we can simply do that vertically. We can add 2x plus 5x, we can add negative y plus y, which makes 0, which is the whole point, and we can add 1 plus 13, okay? So it's very simple, it creates a really simple equation very quickly. So 2x plus 5x is 7x, negative y plus y is 0, that's the whole point of why we chose it, 1 plus 13 equals 14. So immediately we get to a very, very simple equation, but simply by adding the two equations together. 7x equals 14, and so therefore x equals 2, dividing both sides by 7. And then we can substitute x back into either equation 1 or equation 2. There's not an obvious choice here. I like equation 1, it's got smaller numbers in it, so I'm going to substitute it into equation 1. So I've got 2 times x, which is 2 times 2, take away y equals 1. So 4 minus y equals 1. Subtracting 4 from both sides, negative y equals negative 3. Multiplying both sides by negative 1, y equals 3. And so therefore our solution is x equals 2, y equals 3. Okay. In the second example here, so example 4, for elimination, again I'm looking at, right, I've got the same y terms again, but this time they're both negative. So if I were to add those, if I was to do negative 5y plus negative 5y, that's negative 5y minus 5y, which is negative 10y, and it's not 0. So I don't want to do that, that's not going to eliminate. So what I want to instead do here is to subtract, because negative 5y take away negative 5y is negative 5y plus 5y, which is 0. Okay, and so we've eliminated. That's what we want to do. Alright, so we're going to want to subtract the two equations. Again, I'm going to label them as 1 and 2. Now, we could either do equation 1 minus equation 2, or we could do equation 2 minus equation 1. Doesn't matter, both will get us there in the long run, but I like to try and keep things positive. So if I do 3x minus 2x, that's still going to be positive x. So I'm going to do equation 1, take away equation 2. When I do that, 3x minus 2x is x. Negative 5y minus 5y is negative 5y plus 5y, which is 0, which is why I chose to subtract. And on the right hand side, I've got negative 27 minus 23. So that's negative 27 plus 23, which is negative 4. So immediately, just by eliminating, just by subtracting the two equations, I've found what x is. And then I'm going to need to substitute that back in. You can go back into either equation. They're both fairly similar in this case. I'm going to substitute x into equation 2. By all means, go ahead and do equation 1, and let's meet at the other end, and we should have the same answer. So I'm going to substitute x into equation 2, so that's 2 times 2 minus 5 times y equals negative 23. So 4 minus 5y, sorry, that's a 5, equals negative 23. Subtracting 4 from both sides, minus 5y equals negative 27. And dividing both sides, so I'm just going to fix that so it's clear. Dividing both sides by negative, x isn't 2. I got that from the last example. X is negative 4. Not to say the answer couldn't be a fraction. Again, fractions are our friends. They're numbers like everyone else. Okay, so 2 times negative 4 is negative 8. So let's go back here again. So negative 8 minus 5y equals negative 23. Everything's negative, so let's multiply everything by negative 1 just to make life a bit easier for ourselves. Okay, so then I'm going to take away 8 from both sides. 25 minus 8, sorry, it's not 25, it's 23. 23 minus 8 is 15, and dividing both sides by 5, y equals 3. And so we found x and we found y, therefore the solution to our simultaneous equations is x equals negative 4, y equals 3. Again, you should be able to check it. If you substitute those x and y values back into both equations, they should make the equations true. The left-hand side will equal the right-hand side. Okay, so elimination is useful when we have the same term in both equations. We haven't got x or y as the subject, although in this example up here, it would be easy enough to make x or y the subject. In the second equation, we could rewrite that as y equals 13 minus 5x, and then you could substitute. Okay, that would work as well. So it's not to say there's only one way to do it, but it's just about making good, efficient decisions. So if you have the same term in both equations, you're going to want to try to add or subtract to eliminate that term, and then you generally end up with a very simple equation from there. These last examples, or this last two examples, we don't immediately have the same term in both equations. Now, we could easily make x the subject here. X is going to be 5 minus 7y, and then that's x, and we could substitute and then solve from there. But I'm going to use elimination, although that would be a good method to use. Okay, I'm going to stick with elimination, but what we want to focus on is we first of all need to create the same term in both equations. Now, if we know that x equals 7, we can multiply both sides by 5, and 5x equals 35 is still a true equation. Similarly, 2x plus 1 equals 6 is the same as the equation 4x plus 2 equals 12. If you double everything, it's still the same equation, okay? So what we want to do in order to create the same term, even when we don't have it, is we want to multiply one or both of the equations by something. So if I call this equation 1 and equation 2, if I were to multiply this by 3, then I'd have the same term here and I could eliminate. So I'm going to do equation 2 times 3. You can't just multiply part of the equation by 3. If I want to make that 3x, I have to multiply everything by 3. So I'm going to do equation 2 times 3, and that is 3x plus 21y equals 15. Whole equation times 3. I'm going to call that equation 3. I'm going to rewrite equation 1 underneath here. I don't need to do anything to it. Equation 1 is negative 3x minus 2y equals 4. And now I'm poised and ready to be able to eliminate because I've created the same term in both equations. Okay, so I'm going to need to add those to make 0. 3x plus negative 3x is 0. So I'm going to add both equations. So this time I'm adding equation 1 and equation 3, my adjusted equation 2. Adding those will eliminate x. 21y plus negative 2y is 21y take away 2y. So that is 19y. And on the right hand side we're adding 15 plus 4 is 19. So again, very simple equation comes out of the elimination process. Dividing both sides by 19 gives y equals 1. Then once we've got y, we go back into one of our original equations to find x. I'm going to go back into the second equation. It's a nicer equation. I'm going to sub y into equation 2. It's got less negatives, smaller numbers. 7's a bigger number, but there's no coefficient of x, so it's pretty nice. So it's x plus 7 times y, so 7 times 1 equals 5. So that's x plus 7 equals 5. Subtracting 7 from both sides, x equals negative 2. And so therefore my solution is x equals negative 2, y equals 1. Again, you should be able to sub those back into both equations and find that they make both equations true. Alright, last example here, example 6. Haven't got the same term in either equation, so we're going to need to create it. Now, we could make the x terms the same by multiplying the first equation by 7 and the second equation by 3, which would make them both 21x. And obviously we'd have to change everything else. Our other alternative is to make the y terms the same by multiplying the top equation by 3 and the bottom equation by 4, which would make them both 12y, and then we could eliminate. Now I would rather multiply by 3 and 4 than 3 and 7 because it will keep all the numbers a bit smaller. So that's what I'm going to do. I'm going to label them as equation 1 and 2. I'm going to be doing equation 1 times 3, which will make 12y. I'm also going to do equation 2 times 4, which will again make 12y here. I'm not worried about the negatives. That comes into the decision about whether I add or subtract the equations. So we're doing the whole of equation 1 times 3. So that is 9x minus 12y equals 9. And we're doing the whole of equation 2 times 4, so that's 28x minus 12y equals, now 4 times 26, 4 times 20 is 80, and 4 times 6 is 24, 80 plus 24 is 104. You do need to be able to do that level of number work. If you have to write it out, by all means do 26 times 4, but really you should be able to do 20 times 4 and 6 times 4 in your head and add them together. Okay, now we are poised and ready to be able to eliminate. We have negative 12y in both equations. Our next decision is, do we add or subtract? Okay, so will adding make 0y or will subtracting make 0y? If we were to add negative 12 plus negative 12, that's negative 24, so it doesn't make 0, so we're going to need to subtract. Okay, I'm going to call this equation 3 and equation 4. So we are going to do equation, now I can do the subtraction, I can do 3 minus 4 or 4 minus 3. Given that the numbers in equation 4 are bigger, I'm going to subtract 4 minus 3 rather than the other way around. It will work. If you do it the other way around, you're just going to end up with more negatives. 28x minus 9x, that is 19x. Negative 12y minus 12y gives 0y, which is why I chose to subtract. 104 take away 9 is 95. So x is 95 divided by 19, and again that number works a bit big, but I know that 20 times 5 is 100, and so 19 times 5 is going to be 5 less than 100, which is 95. which means if 19 times 5 is 95, that means that 95 divided by 19 is 5. You just need to be able to have a go, okay? It's going to be roughly around 20. Try 19. If it doesn't work, go again. So that equals 5. Once we've got our x value, we can substitute back into either of the original equations, or you can go into these equations, but these equations generally have bigger numbers, so usually you're better to go back to the start and find the value of y. I'm going to go back into equation 1. I think that looks a bit nicer. It's got smaller numbers. So I'm going to substitute x into equation 1, which means that I get 3 times 5. Sorry, that's a 3. 3 times 5. Take away 4 times y, which is equal to 3. So that is 15 minus 4y equals 3. Subtracting 15 from both sides, negative 4y is negative 12. And dividing both sides by negative 4y equals 3. And so therefore, x equals 5 and y equals 3. Now, just to be clear, in all of these examples, they've turned out with nice whole number answers. There is absolutely nothing to say that the two lines wouldn't intersect when x equals a third and y equals a fifth, or whatever it might be. So it's perfectly possible that your answers might involve fractions. There's nothing different about it. You just need to work your way through the number work with the fractions. Okay. All right, so a mixture of questions here, exercise 1J and 1K. They probably, I think from memory, 1J is going to be solving using substitution and 1K is going to be solving using elimination. But I really want you to start to develop that sense of which method is going to be best here, rather than just relying on the question that tells you which method to use. Because realistically down the track, it's not going to tell you which method to use. You're going to find as part of a larger problem that you have need to solve simultaneous equations, and you then need to independently be able to decide what the right method is. There are some alternative older videos on solving equations by substitution and elimination. Those are both linked here in your notes if you want to refer to them for an additional resource.